Hello all. So in the last session we have discussed about one important architecture of NLP, which is sequence to sequence model. So today in the session I would like to discuss about one important application of sequence to sequence model, which is machine translation. Okay. So we will just have some insights about what machine translation is all about. So when I talk about machine translation, it is basically a subfield of computational linguistics that focus on developing systems capable of automatically translating text or speech from one language to another. Most of the times when we talk about machine translation, we only talk about language translation. Okay, so language translation can be of two types. One is text to language translation and speech. Okay, so speech recognition and text machine language translation are two important uh, task of machine translation. Okay, so when I talk about NLP, the main goal of machine translation is to produce translation that are not only grammatically correct but also convey the meaning of the original content accurately. Okay, so when we look into Google translation, which was used in the earlier days, word to word translation was being done, so the context would be missed in the translation. Okay, so that is the reason with the advancement of NLP, when I talk about machine translation, not only the grammar but also the context in the sentence has to be converted when we are translating sentence from one language to another language. Okay, so basically we take one source language with respect to linguistical statistics, AI and NLP, we will be able to convert that into target language. So target language can be anything that you choose. Okay. Now what is the need for machine translation? Okay, so there is lot of data that is existing in the modern world with lot of information that is being used by humans as a medium of communication, right? So the need for translating from one language to another language has become utmost important, for which we have to use NLP to generate the translation with good accuracy. Okay, now one important need for language translation is we travel around the globe where we might not know all the languages. So the only option that we use is Google Translation. When I want to communicate to Koreans or Chinese people where I doesn't know the language, I use my Google Translation, right? So that is one important thing. And it's, if I want to shop any product from other countries where the websites are only, when you go for especially Koreans or Chinese people, the websites are also would be in their local languages only. So in that case, when I want to purchase a product or anything else, I need language translation. Okay, so there are so many documents which are also available in their native languages, using products from across the countries, real time chatting, legal literature and many other use cases require the need for language translation. Okay, now so in the last session we have discussed about sequence to sequence model. So with the advent of recurrent neural networks, variety of complex tasks, for example machine translation, is using this sequence to sequence models. Okay, so as we have already discussed, sequence to sequence model basically consists of encoder and decoder block in their architecture that is used for recurrent, that uses recurrent units in their layers. Okay, now we've also seen this, the encoder and decoder are two different models working hand in hand, whereas the encoder will do different operation, different kind of computation, and the decoder performs different type of computations, right? So the input sequences of words are taken as input by the encoder, and the decoder will typically convert that into the target sequence. Okay, so when I talk about machine translation task, the source language is passed to the encoder as the sequence of vectors or word embeddings, and after that these are passed through these recurrent units inside, that is hidden units, and the end output would be a encoder state representation. Okay, now this encoder state representation is used as input for the decoder, and again these are passed through series of recurrent layers which will produce the output sequence with highest probability. Okay, now what are the key approaches? There are different approaches in machine translation task. So basically we use encoder and decoder blocks only, the two-step process. Okay, so starting from 1950s, when you go for the evolution of these machine translation, we have different types. Basically there are two types, rule based and corpus based approaches. Okay, now we'll look into what are the different approaches that we choose for machine translation. Okay, first is rule based machine translation. Second, we have starting with rule based from 1950s. From 1980s we have example based machine translation, and then taking word, syntax, phrases into consideration, we have statistical machine translation, and then with the evolution of neural networks we have neural machine translation, which basically uses RNNs and LSTMs. Okay, rule based, example based, statistical machine translation, and then neural machine translation. The last one is what we are going to use for machine translations. Okay, so let's look into each of the models individually. When we talk about rule based, they are also called as knowledge based. This was the beginning of the era, okay, where they started working on machine translation. This rule based translation was used, which basically works on linguistic information. Okay, so the target languages are derived from dictionaries, and the grammar is used from the dictionaries for each different language. Okay, so once we have the input sentences in one language, this rule based machine translation will generate the translation to output language considering morphological, syntactic and semantic analysis only. What is that? Morphological, syntactic and semantic analysis. Okay, now taking dictionary and the grammar rules, morphological, syntactic and semantic analysis, we have the rule structure, okay, the language structure generated for RBMT, that is rule based machine translations. The second one is example based machine translation. Okay, now this particular system uses bilingual corpus with parallel sentences. Okay, most of the times when we speak, especially in the speech recognition, I may not use a single language, I may use multiple languages when I talk, beech mein Hindi and then madhilo Telugu and then English and all that stuff, right? So for this we need example based machine translation. Okay, so during this the system will break down the source sentence into smaller phrases and matches them against the examples given. Okay, so for example, I am eating an apple, I am eating an orange. Okay, so the first words in the sentence are same, only the last word is different. Okay, so sometimes the analogy may be different, wherein orange may does not have any word in that particular language, so orange would be produced as orange only. Okay, and the third one is statistical machine translation, or we call it as SMT. Now this works by using the statistical models which will investigate on huge volumes of bilingual context. Okay, so this is one genuine illustration of Google translation that we are using. Okay, so SMT is basically extraordinary for now. However, there are some disadvantages that it does not consider context into picture. Okay, so without context obviously the quality of translation would gradually decrease. So the basic principle behind SMT is Bayes theorem, which will perform the analysis of parallel text, but it does not consider the context into picture. Okay, so the accuracy of this would be a bit reduced as the context is important for language translation. Okay, and the next model is hybrid machine translation, which is the combination of both statistical and rule based to improve the efficiency or the accuracy of the translation. And the last one is neural machine translation, or the models that we develop, sequence to sequence models or any other models that works on this machine translation. We use neural networks. So basically these employ AI techniques. In particular, they rely on the neural network models. You know what neural network model, depending on the analogy of the human brain, with the end goal of translation, we work on NMT, neural machine translation. Okay, so basically this works by incorporating training data. When we talk about neural network, we have training data, we train the model with the training data, and then we give the test data to test our accuracy. Okay, so neural networks, we have different layers. So the input block with respect to different hidden layers, the content would be processed and the output would be generated. Okay, so 2015 to present we are using NMT models. Okay, so when you are using any translation models, see here we have English to Spanish, English to French, English to Chinese. So we have different translation qualities. Even if you use different methods, see there are some cases, there are some languages which may not require context much into picture, which may work well with SMT. There are other languages which may require context into picture, which gives you good result with NMT, neural machine translation. Okay, so this is simple example on how we compare the translation quality using different methods. Okay, so we say machine translation is different because it has many challenges. When we talk about few of the challenges, the words and sentences can be ambiguous. Okay, multiple languages may be used for translation. Okay, that is multilingual sentences. Translation sometimes require deeper analysis. Okay, lack of data if certain languages, because we don't even know the grammar, or how do we pronounce those languages. Okay, and then named entities as well as expressions of time, space, quantity for few languages is difficult to handle. A sentence can be translated in multiple ways, and sometimes the right choice could be subjective. Okay, so these are different challenges we face when we go for speech translation or machine translation. Okay, so hence we say machine translation is basically a difficult task. Okay, so when we look into some statistics, by 2027 the global machine translation market is estimated to be around 3 billion US dollars, 3 billion. SMT alone contributes to more than 65% in market revenue. Machine translation quality was observed in computer software, legal services, telecommunication. Okay, so the most difficult content for MT is to get professional services, instructions, sales, marketing, etc. 93% of Amazon is reported to be the best in likeliness to human translation. Google generated Spanish translation of medical instructions with highest accuracy of 94%. In 2020, the language service providers reported that their use of machine translation for end clients has increased by 13%. Initially, nobody would use all this, but as we have global communication happening between different countries, we go for language translation, and that is increased to 13%. Okay, so this is all about machine translation. Okay, so we will look into how sequence to sequence model works and how do we build our machine translator in the next sessions. Thank you.